Today we're going to be looking at the other type of compound inequality, which is called the AND inequality. They're basically the exact opposite of what you saw yesterday. Yesterday, the OR, you could have an answer that was an answer for one of them or for the other. It didn't have to be the same. The AND inequalities are a little bit different because actually the solutions need to be true for both inequalities you're given. So it needs to be a solution to one and to the other, not or the other. And then the two dots on the graph, you're actually going to find that what ends up happening is you end up shading between them. And I'll show you an example of why that works at some point. Go ahead and hit pause, write that down. When you're ready, hit play and we'll move on to example 1. Example 1 tells you to write an inequality and graph it for this statement. All real numbers that are at least -2 and, here's your key word, at most 4. So if you stopped and thought about answers to this, just stop and think for a minute about possible things that could be at least -2 and at most 4. So go ahead and write down a couple possible solutions that you can think of. Hopefully you came up with things like 0, -1, -0.5, 0.75, 3, 3.2. These are all options. You could go on for a really long time writing down different solutions there. But those are some of the choices. So if we were to write this out the way that you learned yesterday, you would write 2 of them. So you'd look for your important information, which are at least -2, the word and, at most 4. So if you were to write that way, you would say x is at least -2. So something to -2. -2 is the lowest it can go, so everything actually needs to be greater than or equal to it. Then you would be using the word and instead of or. X is at most 4, which means everything here actually needs to be less than or equal to 4. Now this is where it gets a little tricky, and this is where I wanted you to have practice yesterday just at getting used to seeing 2 of them. But the proper form for writing the AND inequalities is a little bit different. What you're going to do is you're going to start using that idea of when I've had you read these, when the variable's over on the right, I've had you read them from right to left. You're going to start using that idea. So you're going to write the inequality with the variable in the middle. And only use less than or equal to signs. So you make sure that you write it with your variable in the middle, and then you're going to read basically backwards, the way that we've been doing when we read from right to left or left to right. So I'm going to show you an example of that right now. Take that variable, bring it down to the middle. You can only use less than or equal to signs. These are both less than or equal to, so I'm just going to fill those in. This is where you have to kind of change your thinking. If I cover this up, x is less than or equal to 4. X is less than or equal to 4. See how that works? Now, this one I'm going to read backwards. This says x is greater than or equal to -2. If I read it from here, x is greater than or equal to -2. So you should be able to read one of them backwards, one of them the way that we're used to reading them, and you end up with both. And the way you read this is -2 is less than or equal to x, which is less than or equal to 4. And again, you can look at it as 1 here, read it backwards as 1 there, and you should have the 2 that you started with. So you're only going to write the and compound inequalities this way. The or ones you write the way we did yesterday, but the and ones, this is proper form for writing these. And if you need to make yourself a note, this was the greater than or equal to originally. Now when we go to graph this, you're going to have your number line. And you're going to put your dots, same thing, open or closed, check it. I have a closed dot at -2, and I have a closed dot at 4. Now, just so that you see how this works, I don't want you to write this in on your notes till we're done, but I want you to understand how this works. If you were to look at just this part, x is less than or equal to 4, you would be talking about all of these. If you were to look at just this part, x is greater than or equal to -2, you would be looking at all of these. Okay, notice we end up with our whole entire graph shaded because this one goes down past -2, this one goes up past 4. With the and inequalities, you're looking for the answers that are true for both. So you are looking for the part where they overlap, which ends up being the part in the middle, which is right there. So those are your solutions to this compound inequality. That's the only part you're going to graph. You never graph these parts. I just did that to show you how that works and why it overlaps. This is a real life example. Today's temperature will be above 80 degrees Fahrenheit, but not as high as 100 degrees Fahrenheit. I wish that was true, but it hasn't been lately. So again, in this case, what you're looking for is there's several answers, several possible answers in here. It could be 85, it could be 90, it could be 98, it could be 99.9, but it's not going to get to 100, and it's going to be above 80. So you're looking to represent all those answers in the middle. And when you go to write the inequality, if it helps you to write it like we did here first and then convert it to this, you can always do that. But you need to make sure your final answer on the and ones looks like that when you write them out. So we can go ahead and write our original ones just as two separate first to help us set it up. The temperature will be above 80. So T is going to be some relationship to 80, and it's greater than, hopefully you are getting used to those now. The temperature has to be greater than 80. It's not or equal to, because it didn't say 80 or above. It said it will be above 80. To be really careful for that. So above 80 is a key. Not as high as 100 is a key. Or I should say, and the temperature is going to have some relationship to 100 degrees. And we already talked about not as high as 100 means less than 100. Again, not going to be 100 because it's going to be not as high. If they said up to 100, then we could add an or equal to, but we have no or equal to here. So when you go to set up your inequality from here, bring that T down into the middle. You have no or equal to signs, so you're just going to have a less than and a less than. And now you have to figure out which number goes on the right and the left. This one is already set up as it is, so I put in 100. When I read it that way, t is greater than 80, that is that one, so I put in 80. And that's how you can set those up every time. Now when you go to graph it, remember, you always need to have some kind of markers showing what you're counting by. So I was counting by tens here. You don't have to graph or label every single one, because sometimes when you start to label every single one, it gets so small it's hard to tell what it goes with. So I'm going to have an open dot, 80 and 100. There's my open dot at 80. There's my open dot at 100. Somewhere between 80 and 100, my temperatures are going to be. So I fill in what's in the middle. And those are all possible temperatures. Go ahead and copy this down on the left right here, and then just pause it while you're copying it and hit play when you're done. It's basically what we talked about there, and it's what we talked about here with writing it once, but I want you to see it on the left side so that you can easily find those examples when you're looking later. I know these are a little tricky, but really always go to start with my variable in the middle and then read to the right and then read to the left, and that should help you every single time. This is example 2. Example 2 asks you to solve and graph, and it's an and inequality. The reason we know it's an and inequality is because we've got one long compound inequality written. Yesterday when we were talking about or, we had two separate ones. And then also you only have less than signs being used. So you can always look for that pattern. Now, write that down. In the past, I've been asking you to draw a line from your equations. Part of the reason I asked you to draw a line from your equations is because I really wanted you to get used to starting to look at where the equations were being split up, or in chapter 3 where the inequalities were being split. If you notice here, if you were using your lines, you would actually end up using 2 lines. Now, the rule that you've been applying, if I do something to one side of the line, I have to do it to the other side of the line, is actually going to be used 3 ways. If I do something to the middle, I have to do something to the right and to the left. Or if I do something to the left, so you're going to see that you've got to move things across evenly. The goal for these is to isolate the variable in the middle of the inequality, just like the ones we just wrote in example 1. There's your variable, and you're going to isolate it using the same rules you've already learned. So if I want r to be alone, what am I going to do with -5? Hopefully most of you said, okay, I'm going to add 5. This is where that rule applies. If I'm going to add 5 here, I'm also going to add 5 here and here. So 3 times instead of 2. And then I'm just going to bring this down. So -4 plus 5 is a 1. Bring my inequality down. Bring my r down. These became a 0. Bring down less than or equal to. You can have a less than and a less than or equal to. That happens a lot. -1 plus 5 is 4. R is isolated, so you're done. Obviously this was a basic example. Sometimes you're going to have 2 or 3 steps in the middle that you need to take care of before the variable is isolated. But this was a basic example just to show you what your goal is and how you're going to get there. So that's your final answer. 1 is less than r, which is less than or equal to 4. And when you go to graph it, I'm going to go ahead and put 0 here. Open dot on 1. But a closed dot on 4 because it's or equal to. And now, following the pattern of what I know with these compound inequalities that are written this way, I know that the middle is what should be shaded. I always check it just to make sure because that might help me catch mistakes if I made any. Try one of the numbers like 2. Is 1 less than 2? Yes, it is. Is 2 less than or equal to 4? Yes, it is. And that should work every time. If you try any number in here and put it in for r, or the variable, these both should work. Or you can read it, is 2 less than or equal to 4? Yes. Is 2 greater than 1? Yes, if you see it better that way. Go ahead and write down what I wrote in on the left here. Once you're done, you can play again. You're going to have to hit pause right now. But I'm going to just go over it really quickly while you're starting to write. So this is what we talked about in this example. You're going to isolate the variable in the middle of the two inequalities. You want it to end up in the middle alone. You're going to use your 2 lines here instead of 1 like we were using before. And that's so that you can isolate and solve moving away twice. And then you're going to end up moving things 3 times instead of 2. You're used to moving things twice. You need to think about that 3rd time now in this one. So go ahead and hit pause, finish copying that down, and once you're ready, hit play. Now that you're finished writing that down, go ahead and copy this example into your notes. Once you're done copying it, hit play, and I'll go over it with you. This example, I shortened it, but if you want to read it in the book in detail, you can go ahead and look it up in the book in this lesson. But it's talking about acidity in water, so something like a pool. And the average of 3 readings, average is a key word there, is between 7.2 and 7.8 inclusive. Inclusive is a key word. If you don't know what that word means, you need to stop and think about it for a minute, or you might even have to look it up at some point. The readings are 7.4 and 7.9. So it only gave us 2 readings, but they said 3 there. So I'm already thinking, okay, wait, so maybe that's what we're missing. Then I keep reading, what are the possible values for the 3rd reading? There's my variable right there. Remember, you can almost always find your variable in that question right there. So what I'm going to do is I'm just going to go through first and look for things that I think are important. Average. Okay, hopefully you found a few other things. 3 readings. The fact that it's between 7.2 and 7.8 and inclusive. I need to figure out what inclusive means if I'm going to do this correctly. And then also that the readings are 7.4 and 7.9. And I'm looking for the 3rd reading. These are difficult. You do have some on your test, so you need to learn how to do them. And here's what you need to think about. The word between means that it needs to be between this and this. It's not any of these answers or any of these. It's an and inequality. So you're going to set it up like one of the and inequalities that we've been talking about. Hopefully everyone remembers how to find an average. If you don't remember how to find an average, I'm going to go over that with you right now. You add up the readings and you divide it by how many there are. So at this point we have 7.2 and 7.8 and some other number divided by 3 when I look at that as an average. If you haven't figured out what inclusive means, I'm going to go ahead and tell you today. But if you ever come across something like this when you're studying and you don't have someone to tell you, use a dictionary, go online, look it up. Inclusive in this case means including these numbers. So it's an or equal to. We can have those as the readings. And so let's go ahead and try to set this up. I would set it up the exact same way that you've always thought about it. It's going to be between 7.2 and 7.8. So I would start knowing that I have 7.2 and I have 7.8. And because I know I'm setting up an and, I know that this has to be less than or equal to, less than or equal to. And remember, the reason I'm adding the or equal to is because of the inclusive word. On these, you're always going to have your smaller number here, larger number here, every single time because of these less than signs. And if you think about it, x has to be less than or equal to whatever is larger, x has to be greater than or equal to whatever is smaller. So that's going to be that way every single time. Now, in the middle is where you want your variable, but it needs to be set up as an average. I'm just going to put this. That's your average. So this is always your lowest. This is always your highest. And your variable goes with the average here. These can be really confusing, but if you really start to slow down and look at them in pieces, like I just did here, it makes it a little bit easier. Go ahead and add the word inclusive over here, which means included, if we want to think of it that way. So a less than or equal to sign, not just less than. So I have this set up, just rewrite this like we had it, and now we need to come up with our average in the middle. You need to define your variable. So some of you might have just decided to use X, or you could use T for third reading, you could use R for reading. It's really up to you. I'm going to go ahead and use an X this time. I'm just going to say X equals third value, or third reading. And now the way that we find out a average is we add up our values, divide by how many we have. So when I go back and look at the word problem, the values were 7.4, 7.9. So I'm going to fill in right here 7.4 plus 7.9 plus that third reading. And I have a total of 3 readings, so I divide by 3. Okay, if you don't understand what I just did right now, go back and read the problem again and look at it. Average, adding 3 things up, this is the one we're missing, divide by how many we have. Now you're just going to solve exactly like you would solve any of these. So you draw your line, you're trying to isolate this variable right here. That's what you're trying to isolate. So how are you going to get that x alone? What's the first thing you're going to have to do? And hopefully most of you noticed we need to get rid of this fraction. So we're going to do a fraction buster, but when you do your fraction buster, you're multiplying it 1, 2, 3 times. Now some of you are going to get confused and say, well, wait a minute, I thought I had to multiply it to every term. You do, but you need to think about this division bar. When you multiply by 3, this whole thing is being divided by 3 right now. So when you multiply that by 3, your 3's cancel, become a 1. Now you're dividing that whole thing by 1. So if you had split it up, you would divide each of them by 3, but then when you multiply each of them by 3, each 3 would become a 1 anyway. So just be really aware of how that works and when and why. So I'm going to go ahead and multiply by 3. So times 3, times 3, and times 3. These 3's cancel and become a 1. Now I multiply 7.2 times 3, and I end up with 21.6 bring down my inequality. 3's became a 1, so I just have 7.4 plus 7.9 plus x left over is less than or equal to 7.8 times 3, which became 23.4. I'm still trying to isolate this variable. I notice I have like terms that I'm going to combine. If you want to do a decimal buster at this point, you can, but you would need to make sure you put a 10 in front of the x, because that's a 1 there. You need to add a 0, so it'd be 10. Or you can just go ahead and keep your decimals. We're going to combine those terms. So I bring everything down. This is where some of you are trying to skip steps. You're trying not to bring everything down every time you combine. I add 7.4 plus 7.9, and I end up with 15.3. Plus x is less than or equal to 23.4. Again, I'm still trying to get this alone, so I'm looking here, and I'm going to subtract 15.3 from this middle, from the left, and from the right 3 times. And when I do that, I end up with 6.3 is less than or equal to x, which is less than or equal to 8.1. So I'm going to rewrite that just without the line there and without it spread out so far. What this is saying is that all possible values for that third reading could be 6.3, 6.4, 7, 7.25, whatever you want that's in between 6.3 and 8.1. Go ahead and try to graph that on your own, and then hit play when you're ready to check it. I would have started with something like this, where I left more space between my numbers because I know I have decimals. Remember, your decimals are all these numbers between 6, 6.1, 6.2, 6.3, 6.4, all the way up till you get to 7. Same thing. So 6.3 wouldn't be quite halfway through. It would be getting a little less than halfway. And it's a closed dot. So I'm going to put a closed dot at where I think 6.3 is, which is probably right about there. Then I'm going to go to 8.1, same thing, just a little bit past 8, because there's 10 of them before I get to 9. So then you should have filled in all of these. These are all the possible solutions, including 6.3 and 8.1. If you go over 8.1, then your acidity is going to be off. If you go under 6.3, your acidity will be off. It has to stay somewhere in this balance. I'm going to have you try one basic solving one right now on your own, just so that you know tomorrow coming into it if you have questions right from the beginning, or if you're going to be able to kind of get started and see. So this is extra practice. I just want you to hit pause and try it, and then play and check it with me. 7 is less than a negative 3n plus 1, which is less than or equal to 13. This one's a little tricky because it actually has a few things you're going to have to think about to keep all the rules in place. So hit pause, try it, get as far as you can through it, and then hit play and watch the rest. So everyone should have started by drawing their lines, and they're trying to isolate n right there. So this is what you're trying to isolate. First term you should have moved is 1, and you should have subtracted 1 3 times. You end up with 6 is less than a negative 3n. This becomes a 0, which is less than or equal to 12. Now you need to divide by a negative 3. This is where it gets a little tricky. When you divide by a negative 3, this flips around, this flips around. Remember, whenever you divide by a negative, you flip your inequality around. You end up with a negative 2 is greater than n, which is greater than or equal to a negative 4. If you got to here, great job, but now you need to take it a step further. You need to use only less than signs. So you need to think of it this way. N is greater than or equal to negative 4. We've been writing it this way. n is greater than or equal to negative 4, n is less than negative 2, n is less than negative 2. That's the final way it should be written. So these moved to the opposite side so that you could still read it the same. N is greater than negative 4, n is greater than negative 4, n is less than negative 2, n is less than negative 2. And then again, when you graphed it, you should have had a closed dot on negative 4. Closed dot on negative 4, open dot on negative 2, and it's all of this in between.